In this example, we need to solve this problem here. It has an equals in it, so it's an equation. It has denominators, so it's a rational equation. And how do we solve those? We find the least common denominator, and then we're going to multiply all terms in our equation by the least common denominator. So to find the LCD, you go to your first denominator, and you know you have to have that in your LCD. So you put x plus 2 in your least common denominator. Go to your next denominator, x minus 3. Do I have an x minus 3 over here? No. So you just multiply the x plus 2 by x minus 3. So that is the least common denominator. Now we have to figure out, are there any restrictions on the values that x can take on in this problem? Well, when you have x in the denominator, you know x cannot take on values that make the denominator 0. So one way to find our restrictions is you take each denominator and set them equal to 0. So I have x plus 2 equals 0. Simple linear equation, subtract 2 from both sides, you get x equals negative 2. Go to your second denominator, x minus 3, set it equal to 0. So you get x minus 3 equals 0, add 3 to both sides, x equals 3. So our restrictions are x equals negative 2 and x equals positive 3. Those are the values that x cannot take on because they will make one of these denominators equal to 0, and you can never divide by 0. So now I'm going to multiply this term and this term by the LCD. So I have my LCD of x plus 2 times x minus 3. And since I'm going to multiply it by a fraction, I turn my LCD into a fraction by dividing it by 1. And that's going to multiply by 6 over x plus 2. And that has to equal 4 over x minus 3 times your LCD, which is x plus 2 times x minus 3 over 1. So now I'm ready to simplify. On the left-hand side, on this term, the x plus 2's reduce, and I get left with 6 times x minus 3. Don't forget that x minus 3 must be in parentheses. Equals, on the right-hand side, the x minus 3 reduces, and I get 4 times x plus 2. So now I've cleared my denominators. All I have left is a simple linear equation. And so what I'm going to do is distribute the 6 into this parentheses. So 6 times x is 6x. 6 times negative 3 is negative 18. Distribute the 4 in on the right-hand side. 4 times x is 4x, and 4 times 2 is positive 8. So I'm going to collect my x's on the left-hand side. So I'm going to subtract 4x from both sides. So I get 6x minus 4x is 2x minus 18 equals 4x minus 4x is 0. So the only thing on the right-hand side is 8. And since I'm running out of room, I'm going to go work up here. So let me rewrite that as 2x minus 18 equals 8. I need to add 18 to both sides. So I get 2x, the negative 18 plus 18 adds to 0 equals 8 plus 18 is 26. Last step, divide both sides by 2. And so I get left with x equals 26 divided by 2 is 13. So before we're done, check it. Is 13 allowed? Yes, negative 2 and 3 are the only values of x that are not allowed. So I have proved that x equals 13 is not extraneous. But to prove this is the correct solution, you'd have to plug 13 in here and here to see if you landed up with a true statement. One last thing I wanted to point out is I solved this by the general method that works on all rational equations. This is a special type of rational equation when you have one fraction equals another, just one term on each side. That is the case where you can cross multiply. And if I did that on this case, I get 6 times x minus 3, which is what we had here, equals 4 times x plus 2, which is what we had here. Cross multiplying is a great method. It's a shortcut method, but it only works if you have one fraction equals another. The trouble with that method is a lot of students like it so much they try and use it when you have 3 or 4 terms in the original equation. It only works when it's set up like this.